It's Monday, 6:23 a.m. I'm a little bit tired, but I'm following my dreams, so everything is great.
I initially wanted to skip the step of installing a foundation beam. It's extra work and effort and takes up time I'm already running low on. But here we are. Because the last layer of blocks didn't quite level out, I need this foundation beam to correct it. First, I'm setting up the formwork around the top of the walls. To make sure it's precisely aligned, I'm placing spacers, each the exact width of the blocks, between two boards. This way, everything will fit nicely on top of the wall. Now, unfortunately, my phone cut out, so I missed filming parts of this process. But the steps are straightforward, and the results will show you how it all came together. With the foundation beam formwork complete, we're making good progress. You can see it set up on top, ready to go. Now I'll disassemble the old footing formwork since I'll reuse those boards to build another set of forms. This time for the pillars that will support the floor beam. Reusing materials has been a consistent approach in this build, saving money but definitely costing extra time. If you remember, I took a similar approach when working on the early foundation layers, adapting boards where I could. It's a bit more effort, but for a solo project like mine, it's worth the saving. It would have been so much easier if I'd fastened the boards from the outside. Now the screw heads are buried in concrete, and I can't always get them out easily. A tip for both you and me: never attach formwork from the inside. Lesson learned. With one task done, we move on to the next. I've inserted long screws between the boards so the formwork can rest on top of the walls. Here's how it works. Two boards squeeze the block, keeping it firmly in place through friction. To get the right height, I used my laser level, adjusting by tapping gently from the top or bottom and tightening the long screws as needed. It went well, though I think it could have been even better. The boards I used had been lying around the site for a year, so some were bowed or a bit crooked. I considered using new boards or even OSB sheets, but new boards add costs, and OSB could be damaged by rain. I didn't know how long this would take me until the concrete pour. So, I settled for a small margin of error, knowing the foundation beam might be out of level by about plus or minus 3 millimeters. Days passed, and I spent every bit of free time, before and after my regular work, on the construction site. Each day, just a small step forward. Now, I'm preparing the steel reinforcement for the columns that will support the floor beam. There will be 5 posts in total, each with 4 steel rebars and 5 steel reinforcements. I remember the first time I worked with steel rebars, when I was preparing the footings for my foundation. Back then, I had no idea what I was doing. Now, I feel much more confident. However, this time it's a bit different. Instead of a square shape, these reinforcements need to form a cylinder. As always, I searched for the most efficient setup for the job. Having them standing up was a challenge to manage, so I switched to a more practical horizontal position. For those who are new here, I'm Greg, and I'm on a journey to build my small house completely on my own, with zero prior building experience. This is my first big DIY project, and it's something I've always dreamed of doing. In 2023, I made the life-changing decision to take the plunge, and by 2024, After receiving my building permit, I started turning my dream into reality. It's been a challenging yet rewarding adventure, and I'm learning everything step by step as I go. And don't forget to subscribe to follow along and support my journey. Three out of 5 steel pillars are ready to install, and 2 are already standing in position, though not yet connected to the footings. Now that all the steel pillars are prepared, I can start placing them. It's 8:30 a.m., so I need to run to work. During the concrete footing pour, I prepped small footings specifically for these pillars and filled them with concrete. The next step is to drill holes in each footing to anchor the rebars securely. Did you notice how my hammer drill is bouncing around? I think it's finally given up. It's a cheap market tool that's actually lasted longer than I expected. Working with this broken drill was far from comfortable, but I had to make do with what I had. Honestly, I'm a huge fan of tools from Rollplug. Their quality seems incredible. I'd love to work with them, but right now, I can't afford to invest in premium tools. And anyway, I've got to admit, I have a soft spot for the color blue. Hehe. The days are passing, and I'm working whenever I can, slowly but steadily, making progress. 2 of the 5 pillar footings are still empty, so I'll pour a little concrete into them first to make the pillars stable. For the footings that already have concrete, I'll use epoxy glue to secure the steel pillars firmly in place. As always, proper cleaning is key before applying the glue. Any dust left in the holes will weaken the epoxy's bond, so it's crucial to get them spotless. For this task, I'm using my favorite Kohlner epoxy. It's super strong, reliable, and incredibly easy to work with. A great choice for ensuring a robust foundation. One Saturday, I brought the kids along to the building site and spent some time cutting the boards to size for the formwork. But that was just the preparation. Today, I'm assembling the boards. According to the blueprints, the pillars should be 25 centimeters wide. However, since my boards are 15 centimeters each, doubling them gives me 30 centimeters, and I decided to go with that. A bit of extra width won't hurt. It might even make them stronger. To ensure stability, I'm adding 2 reinforcements. One near the bottom, where the pressure from the concrete will be the greatest, and another near the top to keep everything aligned and secure. I started assembling the formwork for a random pillar, but I forgot I picked the most challenging one to begin with, the infamous pillar of struggle. This particular pillar isn't perfectly centered with the others, and, to make matters worse, it's the only one that's not level. As always, I'm showing you my mistakes and unexpected challenges. This is another example of theory meeting reality, and things didn't go as planned. I began by marking where the boards should go, then installed the bottom plates to support the entire formwork. I aligned the sides carefully with my markings. However, I forgot one critical detail. When measuring the height earlier, I planned for the boards to sit next to the bottom plate, not under it. That was my first mistake. On a positive note, I added extra reinforcement at the bottom, where the concrete will exert the most pressure. These extra pieces of wood help secure the bottom plate to the sides of the formwork. This worked well, and I definitely stick with this approach in the future. Learning from past experiences, I made sure all screws were placed on the outside so I could easily unscrew them after pouring the concrete. No more buried screw heads this time. Next, I started assembling the sides and screwing them together. But here's where things went wrong again. Instead of creating a square, I ended up with a rectangle. I didn't take a good photo of this mistake. It's even hard to explain verbally. So here's a quick drawing to clarify. This is how I connected the boards. And this is what I wanted to achieve. Notice how the sides are misaligned in the first version? It was frustrating, but a good reminder to double check everything as I go. The formwork for the pillars needed proper reinforcement to ensure stability and accurate leveling. To secure it, I drilled holes through both the boards and the concrete slab, allowing me to fasten everything down using quick fasteners. For each pillar, I also added an extra bracing for additional support. After learning from my first mistake, I can now show you the correct process for assembling the pillar formwork. I started by screwing together two sides. This time, I carefully chose the correct board sides to ensure proper alignment, following the diagram I showed earlier. To make things easier, I partially inserted screws at first, aligned the corners, and then tightened them fully. To act as a third hand, I used clamps to hold everything securely in place, ensuring the corners stayed tight and aligned. bracing was added to aid in leveling the pillars. The first and last formworks had double bracing for extra stability. Once the main part of the formwork was assembled, I attached it to the bottom boards. The primary purpose of these bottom boards was to prevent the concrete from spilling out at the base of the formwork. With all the pillars in place, I leveled them and braced them together using long boards to form a single solid structure. For leveling, I relied on my laser level to ensure everything was plumb. Although this laser isn't ideal for outdoor use, its beam tends to waver in the wind, I was lucky this time. The weather was calm and I was able to get precise results. And the big day finally arrived. Concrete pouring day. Beforehand, I prepped the site by filling all the larger gaps and holes in the walls and formwork with foam. This step was crucial to prevent the concrete from spilling out and creating a mess. I scheduled the concrete pump for 7 a.m. with the plan to get everything done quickly and still make it to work on time. But as you might expect, things didn't go according to plan. During my first concrete pour for the concrete slab, I ordered too much. Learning from that, I calculated everything precisely when ordering the concrete for the foundation footings. This time, the foundation beam and pillars, I was confident the numbers were spot on. Can you guess what went wrong this time? I started with the pillars, filling just the bottom parts. The idea was that the concrete would settle nicely, fill any gaps, and begin curing while I tackled the rest of the pour. It was a calculated approach to avoid putting too much pressure on the formwork. Then I moved on to the walls, filling them up to 70%. And that's when disaster struck. We ran out of concrete. I was stunned. The math was simple and I had double-checked everything. How could this have happened? Luckily, the concrete supplier had a truck available, so I called to order an additional 2 cubic meters. My initial order was 4 cubic meters, so I figured the extra load would be more than enough. I made a quick phone payment and waited for the truck to arrive. While waiting, I tried to make the most of the time by using a long steel rebar to settle the concrete, ensuring it filled every corner and gap. I had underestimated how exhausting this process would be. It was truly hard work. By now, time was slipping away. I was supposed to be at work already, but here I was, still on site. Finally, the next truck arrived. We resumed pouring, and, unbelievably, we ran out of concrete again. At this point, I was furious and completely deflated. Another call to the supplier, another order, and another wait for a truck. This time, I decided to order more than I thought I needed, just to avoid running out again. By the time the final truck arrived, I was already 2 hours late for work. But at least I was able to finish the pour. In total, I ended up using 8 cubic meters of concrete, double my initial calculation. Something clearly went very wrong with the math or the actual measurements. After the walls and pillars were filled, I still had to smooth the top of the foundation beam. To do this, I had to unscrew and rescrew every single bracing of the formwork. This was something I had somewhat accepted when assembling the formwork, knowing I didn't have enough wood to do it the proper way. This was, without a doubt, the worst day I've had on this construction site. A task I had planned to finish in 2 hours took 5. The weather was miserable, the costs doubled, and I was completely drained, both mentally and physically. But on the bright side, the job is done. The foundation walls and pillars are finally ready, and I can move on to the next phase of the project. Every challenge brings me closer to realizing my dream. If there's one thing I learned today, it's this. No matter how much you plan, construction always has surprises in store. Stay patient, stay focused, and eventually you'll get there. When I got back home, only one question kept circling in my head. What happened? The only variable I hadn't directly measured myself was the block filling ratio. When I ordered the blocks for the foundation walls, the manufacturer's specs clearly stated that I'd need 0.08 cubic meters of concrete per 1 square meter of wall. That number was my baseline, but now, after the day's fiasco, I had to dig deeper. I double-checked the manufacturer's description. It still said 0.08 cubic meters. However, curiosity led me to compare other manufacturers' blocks. That's when I discovered something shocking. The filling ratio for similar blocks ranged closer to 0.15 cubic meters per 1 square meter. I recalculated everything based on this new information. And guess what? The math added up to exactly 7.9 cubic meters of concrete. Now it all made sense. The original specs were way off, and I'd relied too much on them. Lesson learned. Never trust specifications blindly. Double check everything. From now on, I'll measure, verify, and triple check every single detail myself. Thanks for sticking with me through this wild journey. Don't forget to like, comment, and subscribe to see what's next.